Hey guys, in this video we're going to be talking about adding and subtracting polynomials, as well as writing them in standard form and classifying them by degree and number of terms. So the first thing that we talk about in this section is writing polynomials in standard form, which we've kind of talked about before. Remember, that just means to write each term in order from biggest exponent to smallest. So for this first example here, 3 is the biggest exponent, so that's the term that I'm going to write first. The sign that's in front of the term stays with the term, so since it's positive, it's going to remain positive. Then I'm going to go over to this squared, plus 2x squared, then comes the 7x, and then minus 5, because that 5 is negative. Same idea here. The only thing with an exponent is this 3x, so it's going to come first, then plus 8. Squared comes first, so 4x squared. Then we have two linear ones here, negative 7x and negative x, which together make negative 8x, and then bring down your minus 5. And then finally, the last one here, 7 is the biggest exponent. Note that there's a negative in front of the 2. It's got to stay there. So negative 2x to the 7th, then comes the positive x to the 4th, and then the positive 6x to the 3rd. So that's a review. We've done that before. The next section starts to talk about classifying polynomials, and we do that in two ways. We classify them by degree, or biggest exponent, and by the number of terms. So degree is always talking about the biggest exponent. And there are 4 vocabulary words that you're going to need to know for these. First of all, if you have a degree of 0, in other words, you do not have a variable with an exponent, that's called constant. That's not a really new word. You've heard it a lot. That's when you just have a number. For example, the number 3. There's no variable and no exponent written there. Technically, this is 3x to the 0 power, but we don't write out the x to the 0. Degree of 1 is called linear, also not new to you. That would be like 3x, or 3x to the first. A degree of 2 is called quadratic, which is what we're going to spend a lot of time talking about the rest of this semester. That example would be 3x to the second power. And then lastly, we have cubic, which would just be 3x to the third power. Now note, if you have anything bigger than 3 for your exponent, you just call it what it is. So for example, if it were 3x to the 6th, I would call it a 6th power or a 6th degree. Also know that you can have more than one term in each of these, except for the constant one. It's all about the biggest exponent that you have, and you're going to name that one. And we'll see that when we get down here in the practice section. There are also 4 vocabulary words that we're going to use to classify number of terms. They are, let's see, a polynomial with one term is called a monomial. So remember, mono means one, nomial means term, so one term. So for example, that could be just 3x. Something with 2 terms is called a binomial. Once again, bi means 2, nomial means term, so 2 terms. So that could be like 3x plus 4. There are 2 terms there. Polynomial with 3 terms is a trinomial. Tri meaning 3, nomial meaning term, so 3 terms. So like 3x squared plus 4x plus 6. That's an example. And then lastly, if you have 4 or more terms, we call that polynomial, which just means many terms. So 3x to the third plus 2x squared plus 3x plus 4. And you can have minuses in there. I just kept choosing plus. All right, so let's practice that. Down at the bottom of the page here, it says, classify the following polynomials by degree and number of terms. So it's always 2 words. 1 from the degree vocabulary, 1 from the number of terms vocabulary. So keep that in mind. So the first example is the number negative 3. It doesn't have a variable written with it, so that means it's a constant. And there is just 1 term there, so that's monomial. Okay, next one, negative x plus 1. This is negative x to the first, making it linear. And I have 2 terms. Remember, terms are separated by addition and subtraction. So I have 1, 2 terms. That makes it binomial. Okay, next one, we have x squared plus 3. 2 is the biggest exponent. That makes it quadratic. And once again, I have 2 terms, so that's a binomial. All right, next one. Biggest exponent is 3. That is cubic. And there are 1, 2, 3, 4 terms, so that's polynomial. Last one here, biggest exponent is 2, which is quadratic. And there are 1, 2, 3 terms, so that's trinomial. Now keep in mind, guys, the biggest exponent doesn't have to be on the first term. It could be with any of the terms in the polynomial. You're just looking for whatever the biggest one is and name it based off of that. All right, now let's talk about adding and subtracting. First, we'll talk about adding. When adding polynomials, basically what you're doing is just combining like terms and then writing your answer in standard form. So for each of these, you need to pay attention to the symbol that's in the middle of the parentheses. Now these are blocked off, so I know that they are addition, so I don't really have to worry about it too much. But when you're doing practice later on, they will be all mixed together, so you got to pay attention to what the sign is. Anytime your sign is addition, all you need to do is combine the like terms. And since I need it written in standard form, I always try and do from biggest exponent to smallest to save myself a step at the end. So the biggest exponent in this one is squared. I have 2x squared and I have negative 4x squared, which together makes negative 2x squared. The next biggest exponent is to the first. I have an x and I have a 3x. That makes 4x. And finally, I have a negative 8 and a positive 2, which is negative 6. And that's it. Next one, biggest exponent is 2, but this is the only one I have, so it's 4x squared. Then I have a 6x, and it doesn't have any like terms either, so it's just plus 6x. And then I have negative 7 and positive 9, which makes plus 2. Next one, biggest exponent is 2. It doesn't have any like terms, so I just bring it down. Then I have a 2x and a positive x. That makes 3x. And then 1 minus 3 is negative 2. All right, biggest exponent here is also squared. I have 5x squared plus negative 2x squared, which is 3x squared. Then I have a negative 2x and a positive 3x, which is just 1x or x. And then I have a 4 and a negative 1, which makes 3. Last one here has a lot going on, but you do everything exactly the same. The biggest exponent is 2. I have 7x squared, an x squared, and a negative 17x squared. So 7 and 1 make 8, minus 17x squared is negative 9x squared. Then I have a 15x and a negative 15x, so those are going to cancel each other out because that's 0. And I have no other x's. Then I have 5 and 24, which makes 29. All right, now subtracting polynomials is the very same idea, except there's one additional step. If you can do this without doing the additional step, that is fine, but be very, very careful as it's very easy to make mistakes with these types of problems. So when I do these, what I like to do is imagine that there's an invisible 1 here and distribute that to each term behind it. The first 3 terms are going to stay the same. So 3x squared plus 2x minus 6. And then basically the signs of everything in the second set of parentheses are going to change to the opposite sign. So negative x squared minus 2x and minus 3. Then I do exactly the same thing I did above. Combine the like terms. Biggest exponent to smallest. So 3x squared and negative x squared make 2x squared. Then I have 2x and negative 2x, which is 0. And negative 6 and negative 3 make negative 9. All right, same idea for this next one, except now there's a 5 here. So I'm not just multiplying by negative 1, I'm multiplying by negative 5. So I have 3x squared plus 2x minus 6, then negative 5x squared plus 30x minus 20. All right, here we go. 3x squared and negative 5x squared make negative 2x squared. Then I have 2x and 30x, which makes 32x. And finally, negative 6 and negative 20 make negative 26. Okay, same idea for the next one. Distribute that negative. So I have 6x squared plus 4x plus 5, that doesn't change. And then the signs are going to change for each of these. So negative 2x squared plus 5x minus 1. So I have 6x squared and negative 2x squared, which make 4x squared. Then I have 4x and 5x, which is 9x. And then negative 5 and negative 1 is negative 6. Same idea. Here we go. Oops. Doing it 4 times this time. So 3x cubed minus 4x squared plus 3 stays the same. And I have negative x cubed minus 3x squared plus x plus 4. Remember, each sign is going to change there because of that negative in front. Combine like terms. This time the biggest exponent is 3. So I have 3x cubed minus x cubed, which is 2x cubed. And then I have negative 4x squared and negative 3x squared, which is negative 7x squared. And then I have an x. It's the only one like it, so bring it down. And then 3 and 4 make 7. Last one here has 2 subtractions going on. So this one gets distributed to that parentheses. Well, this one gets distributed to that one. The first 2 terms stay the same. So x to the third minus 6x. And then the signs will all change for the rest of them. So negative 2x cubed minus 9 minus 4x squared minus x cubed. Okay, combine like terms. We have x to the third, negative 2x to the third, and negative x to the third. These 2 will cancel each other out, leaving me with negative 2x to the third. Then I have negative 4x squared. It's the only one. And then negative 6x, and then minus 9. All right, finally, let's combine adding and subtracting polynomials. You can do both in the same sentence. So all you need to do, like I said, is pay attention to what sign is going on in the middle. If it's addition, leave it alone. If it's subtraction, distribute that negative, rewrite everything, and then combine like terms. So the first 4 terms here are going to stay the same. So 3x squared plus 2x plus x squared plus 3x. And then the last 2 terms will change signs. So negative x squared and plus 3x. Now let's combine like terms. 3x squared, and negative x squared. These 2 cancel, leaving me with 3x squared. Then I have 2x and 3x, which is 5x, and then plus 3 at the end. Next one. I have a 2 out in front here, so you got to remember to distribute that. The negative gets distributed here, and nothing happens to the last 2. Those are the only 2 terms that stay the same. So over here, I'm going to get negative 2x squared plus 4x. Then these signs are going to change. So plus x squared minus 3x plus 1. And then these last 2 terms stay the same. So plus 2x plus 4. Biggest exponent is 2. So negative 2x squared and x squared make negative x squared. Then I have 4x, negative 3x, and 2x, which make 3x. And then I have 1 and 4, which make 5. All right, last one. We've got a lot going on here. Nothing's happening the first 3 terms. Negative 6 is getting distributed here, and 3 is getting distributed here. So the first 3 terms stay the same. Negative x squared minus 9x plus 10. And then I'm going to get positive 24x minus 18 once I distribute this negative 6, and then distribute the 3. So plus 3x squared plus 12x and minus 21. Now let's combine our like terms. I've got negative x squared and 3x squared. That makes 2x squared. Then I've got negative 9x and 24x and 12x, which makes 27x. And then I've got 10 and negative 18 and negative 21, which is going to make negative 29, assuming I can do math. And that's it. That's how you classify polynomials by degree and number of terms, and how you add and subtract polynomials as well.